Welcome to IS112 Computer Networks. For this week, we're going to look at how to subnet your network. During this presentation, we'll explain and examine why to use subnets, how to properly plan a subnet, the binary calculations that are needed to compute and set up a subnet, and the subnet basics, including an example of how to accomplish this. Subnetting is a good practice to improve a network's performance and reliability. On a flat network design, all broadcast traffic is sent throughout the entire network. On a subnetted network, traffic is isolated to each subnet. For example, all security camera traffic would be on its own subnet, while the wireless network traffic would be isolated to its own subnet. This not only improves security, but helps manage network traffic. A well-designed network isolates traffic from the subnet, thus improves the performance and reliability of the network. Before setting up your subnets, you need to plan it out. This consists of two steps: the desired segments and the number of hosts per segment. Plan out how you wish to segment your network. In the above example, there are many segments, and you can see them right here. In this case, there's 3 segments. Each segment has a specific purpose for that type of network traffic. For example, only security camera traffic goes on that subnet. The next step is determining the number of hosts or devices that will be needed on that subnet. For example, you may determine that on the security camera subnet that you will have about 500 devices. So each one of these subnets will have a certain number of hosts or devices, and you need to design your subnet so that it can handle that number. In order to subnet a network, you need to understand binary numbers. A binary number is either a 0 or a 1. That's the only 2 digits that you have in the binary numbering system, or commonly called base 2 numbering system. In the examples above, you know that each position has a value. Let's look at this one right here. In the rightmost position, that is 2 to the 0 power. 2 to the 0 power in decimal is equal to 1. If there's a 0 in this column, then that's equal to 0. If there's a 1 in this column, since it's 2 to the 0, the decimal value is 1. Moving over to the right, to the left one, you'll see the next column. So it goes from 2 to the 0, and now we're in this column, the second column to the right, which is 2 to the first, which is equal to 2. So in this case, there's a 0 in the ones position, and there's a 1 in the column that's worth 2, so it's a decimal value of 2. The next number, which is 00000011, is actually the decimal number 3, because you have 1 in column 1, which is the ones position, and 1 in column 2, which is the 2 position. This last one here is actually decimal 4, because it is 2 to the second power, and 2 to the second power is 4. So when we're working with subnets, you're going to need to be able to convert from binary to decimal and decimal to binary. On this next slide, we're going to look at how networks are normally set up. They're normally set up with 32 binary positions. Each one's normally considered, each segment, there's 4 segments. Segment 1, 2, 3, and 4 consists of 8 binary numbers. If you look at the first one here, it's all ones. And we convert all these ones, and it's equal to 255 in decimal. So in this case, we commonly call this the subnet mask, and in this case, it's 255. The next one has all ones, so that's 255. The next one has all ones, which is 255, and the last one has all zeros, which is 0. So the subnet mask in this case is 255, 255, 255.0. This is an example of a flat network with no subnets. Okay, so let's now look at some of the binary example above. Notice how I said the first 3 octets are used for the network. Notice how the network portion is all ones. That's all subnetting is. So let's look at that again. Okay, so you see we have a subnet mask of 255, 255, 255.0, and this is commonly referred to as the /24 network because the network portion of the subnet mask is 24 binary digits. The host portion of the network has 8 binary digits. By default, an IP address and subnet mask for a Class C address looks like this. The IP is 192.168.1.1. The subnet mask is 255, 255, 255.0. In binary, this looks like, and you see the IP is defined right here, and you say, well, that 1 and that 1 is 128 plus 68, which equals 192, and then you have the various ones on here, which is 168. You see only the 1 is here and the 1 is here, so it's, you see how we got to that decimal equivalent, and then you see the subnet below. Given that I have a single octet for my host portion of the above example, I can only have 256 hosts. 256 is the max value of that octet, counting from 0. But there's another small trick. You need to subtract 2 host addresses from the available ones, currently 256. The first address in the range will be for the network 192.168.1.0, and the last address of the range will be the broadcast 192.168.1.255. So you really have 254 available addresses for hosts in this one network. And again, I've highlighted this. 1 is reserved for the actual network, and 1 is reserved for the broadcast. Let's take a look at this. The /24 is called CIDR notation. Rather than referencing the 255, 255, 255.0, we just reference the bits that are used for this network. In this case, we need 24 bits, 3 times 8, from a 32-bit address. Writing this out in binary, we see right here. Next, we know we need to figure out how many subnets we need. Looks like 4. Since we need to create more networks, currently we have only 1. Let's flip some bits. Okay, so we go through and we use, if we use 0 bits to the left, the first position, we only have 1 flat network we see here. If we have a 1 in the first position on the last octet, that makes it possible of 2 networks, and then if we have the first 2, it's 2 to the second. We'll now have 4 different networks which we need, and we refer to this now as the /26 network. Now that we've decided on a /26, let's start allocating hosts. A little simple math. We have 6 bits to allocate in each network for hosts. Remember, we need to subtract 2 for each network. So we have 2 to the h power minus 2. The hosts available are 2 to the 6 minus 2, which equals 64 hosts. And finally, we have 64 hosts in 4 networks for the 192.168.1.0/26 network. Now we need to figure out where the hosts go. Back to the binary. So right here we know the first address is the network address. Then we go for the first one is 1, next one 2, next one 3. We keep on going until we hit 62nd host address, which is the last usable one, and then we go to the broadcast address. Then we go on to the next one, the first IP address, and that's the network address. We do the same process again. We get to the 62nd host IP address, and then the last IP address is the broadcast address. And we continue this for all 4 networks. In summary, most networks have subnets to make them more efficient and easier to support. Make sure to plan out your subnets first. Binary calculations are needed to calculate a subnet. Subnet basics need to include hosts and networks. We have now finished this presentation, and like always, I recommend to apply what we've gone over outside of this class.